Today we are talking about limit laws, and here they are. There are 6 of them, and this might all look a little bit complicated, but it's actually pretty simple. What this first limit law says basically is that if you add 2 functions together and you want to find the limit of that added together bunch of functions as it approaches some number, it's the same as the limit of the first function plus the limit of the second function. So let me try to give an example of that. So if you wanted to find the limit as x approaches 0 of, let's say, f of x, maybe you knew that that limit as x approaches 0 is 2, and you want to find the limit as x approaches 0 of g of x, and you know that that's 3, the limit of, as x approaches 0, the limit of f of x plus g of x is just those 2 limits added together. So that would be 5. And the same goes for the other normal mathematical operations. For subtracting 2 functions, you can just subtract the 2 limits of the individual functions. For multiplying a function, you can multiply the limits of the 2 functions. Law 3 is a little bit different. This c is a constant. Basically what that says, if you have, let's use f of x again. We know that the limit of that as x approaches 0 is 2. The limit of 2 times f of x as x approaches 0 is just going to be 2 times that. It's going to be 4. So you just multiply. And this same thing goes with division. You divide the individual limits to get the limit of the quotient. And then this one here, it says the limit of c, so that's a constant, just a plain number, is c. So how does that make sense? So let's think about that for a second. If we have a function that equals a constant, f of x, let's say equals 3, if you were to graph that, we'd have 3 here. It would just be a solid line right across. Well, I didn't hit the 3, but you know what I'm trying to do there. It'd be a solid straight line across here. The value of this function is always 3. So the value it's approaching is always going to stay the same, and it's going to be that constant. Okay, so those are the limit laws. Let's see how they work in some problems. So here we've got 3 different functions, f of x, g of x, and h of x. We have limits of them all where they approach 2, and we have the values for those. So the limit of f of x as x approaches 2 is 2, for g of x is -1, and for h of x it's 8. And in the first problem, they want the limit as x approaches 2 of h of x plus f of x. So we just take the limit of h of x and the limit of f of x as they approach 2, and we add them together, 8 plus 2, so that's 10. There's nothing harder to it than that. Let's try the next one. Looks like we've got a constant multiplied by 2 functions multiplied together. So let's do this a bit at a time. And this is all as x approaches 2. Let's get the limit of g of x as x approaches 2. That's -1. And then we want to multiply that by the limit of f of x as x approaches 2, which is 2. And then we want to multiply that by the -9. And that all is going to be positive 18. For this next one, we have a quotient, and we also have something funny going down on the bottom. We have the function minus some value. Again, we can just replace these function names with their limits here and do the rest of the calculation. So as x approaches 2, the limit of g of x is -1, so that's going to go on top. Of h of x is 8, and then we've got a -8, so that's going to give us -1 over 0, which is not a number. It doesn't make sense. So this is actually where you press the does not exist button, because this limit does not exist. All right, let's do one more. So here we have limits of 3 functions where x approaches -3. And first we want a product here, g of x times f of x. So we'll take that value of the limit at -3, or as x approaches -3, which is 4 of g of x, and multiply it by the value for f of x, which is 0. 4 times 0 is 0. So that one's 0. Now we have a quotient here, so we're going to take the value of the limit at -3 of h of x, which is -1, and put it over the value for f of x, which is 0. We can't have 0 in the denominator, so this is a does not exist. And then finally, we've got a lot going on here. We've got some constants. We've got some subtraction going on. So let's just start putting in the limit values here. As x approaches -3, the limit of h of x is -1. and that's multiplied by 3, and then we have a 5 here, and the limit value of g of x approaches negative 3 is 4. So we're going to have negative 3 minus 20, or negative 23. So that is some work with finding the limits of expressions using limit laws.